Hi folks, in this video we continue numerical translation by looking at the phrase at most. For example, see if you can translate at most 6 people are guilty. If you tried to write that out, how many quantifiers and what type would you need? Pause your videos to see if you can figure that out. Okay, let's talk about the answer. In order to do that, you would actually need 7 universal quantifiers. That might not be very intuitive. It might be mysterious why that's the case. And I think translating at most is a little less intuitive than translating at least. If I say at least 6 people are guilty, at least tells me that I need to know of the existence of 6 or more people. So I need 6 existential quantifiers. But why does at most use the universal quantifier? And why does at most 6 use 7 instances of those quantifiers instead of 6? Well, let's talk about a simpler case to see if we can make this a little bit more intuitive. If I tell you at most 2 people are guilty, that does not actually tell you that 2 people are guilty. Maybe one person is guilty. Maybe nobody is guilty. So, just at most 2 means 1 or fewer. So having 0 guilty people is consistent with this. So that's why I don't actually want any existential quantifiers. At most 2 people being guilty does not entail the existence of any guilty people. Instead, what I need is a kind of hypothetical claim. It's not obvious in the English that there's a hypothetical or conditional claim here. But if you think about the logical structure of this, it makes sense. Because what would make it the case that at most 2 people are guilty? Well, what if 3 different people were all guilty, or 3 objects were all guilty? Then we would have to know that at least 2 of those were the same object, because otherwise there could be 3 different guilty things. So if I have 3 variables, x, y, and z, and they all pick out guilty things, then x or y has to pick out the same one, or x or z, or y or z. Some of those have to be the same. Of course, remember, our disjunction is inclusive, as always. So maybe X, Y, and Z are all identical. So if there's just one guilty person, that would also make this true. If there's no guilty people, this thing would be true. So because remember, if there's a false antecedent here, then this sentence is going to be vacuously true if there's no guilty objects. So this actually does capture the structure of at most 2. There's another way to think about this as well, which maybe is going to make more sense to you. So technically speaking, if you want to translate at most 2, you need 3 quantifiers, but they don't have to be universals. If the negation is wide scope, these things could actually be existentials. So because if I say at most 2, then it can't be the case that 3 people are guilty. So if I actually say 3 different people are guilty and negate it, then that actually captures the exact same force. So these 2 sentences are logically equivalent with each other. You could create a chain of equivalences that actually proves this equivalence using the principles that you've already learned in this class. So at most, technically speaking, has 2 different ways of translating it, and you can use whichever one makes the most sense to you. I will keep calling the first one here with 3 universal quantifiers for at most 2, or 7 universal quantifiers for at most 6 as the canonical form. But if it helps you to make that more intuitive by thinking about the negation of 3, then that's great too. Okay, thanks.